Greetings of the day. Welcome you all for the 8th video of learning Swift programming language. So these are the topics that we have covered in the previous videos. From the video 1 to video 4, the topics I have listed here, and the topic covered in the video 5, 6 and 7 are listed here. Let's move to the today's topic. The topic that we are going to see today is classes. Classes are similar to structures. That is, they allow to create new data types with our own properties and method. See, the syntax of class is we need to mention initially the class keyword and after that the class name, and within the curly braces we can mention the properties and methods. The major difference between the classes and structures are, see, this is a structure and this is the class defined here. For the structures, as we know, we will be getting the default member-wise initializer. But for the classes, we need to explicitly mention the member-wise initializer in order to provide values for the properties. Creating instance for a class and a structure is similar. See, we have the instance name here and we have mentioned the class and we have mentioned the structure here. So the instance creation is same for structure as well as classes. Also, we know that at the time of instance creation, all the properties of that class or structure need to have a value. That is the purpose of initializers as well. See here, for the class and structure, I have provided the default value so that I can create the instance like this. So I don't want to provide any values here. The default value will be assigned to this instance poppy. The same for structure as well. But in structure, that itself will give the member wise initialization so that I can use both of these initializers. So if for this poppy, the default values will be taken, but for this doggy, we can, with the help of default member wise initializer, we can provide the name and breed in separate. This is the class and structures. The another major difference between the classes and structures are classes will be termed as reference types and the structures will be as value types. Let's explain this in code. Here we have defined one class of car. It has the properties of year, make and color, and we have initializer here and we have created the instance. So for this car we have created the class with values as 2023, make as Tata and the color as gray. We have assigned this instance to a stolen car. That is, my car is got stolen now. After getting stolen, I am changing the color of the stolen car. So the stolen car dot color I am changing. So my car initially I have created here. After that my car gets stolen, and for the stolen car I am changing the color. So what will be the color of my car? If we print this, yes, you are right, we'll get the color as red. My car color now become red. That is, I have created an instance of my car. That my car I have assigned to the stolen car and then changing the color of the stolen car to red. So now my car color will also change to red. This is the reference type of classes. Let's see the same example in structures. See here, in structure we have defined three properties: year, make and color. We don't want to provide any initializer, so directly we are creating the instance here with the same values: 2023, make Tata, and then the color will be gray. So now our car is getting stolen. That is, I'm assigning the my car to the stolen car and changing the color property of the stolen car to red. And while I print this, the color of my car, I'll get the result as my car color always will be gray. This is because of the value type. Classes are similar to Google Sheets and structures are similar to Excel. That is, if we create some Google Sheets and share it to somebody, and if they change something in the sheet from their end, it will reflect in our Google Sheet as well. But in the case of structure, that is the example of Excel, if we did something and if we send it over the mail or something to others, if they change from their end, it doesn't reflect to our Excel. So this is the example of reference type and value type. Now we have understood about the reference type and value type. Let's see the example here. Here I have defined a class of my class. It has the properties of value, and here I have created an instance. This instance is a constant and I provide the value of 5, so that this obj will hold a reference to this class. So that is the reference type. That is, this obj instance I have created here as a constant, and this obj will store the reference where this class is stored. That reference will get stored here, so that even this is a constant, I can change the properties here. This will work. This doesn't cause any errors. But let's see the same case in structure. As we know, the structure is a value type. Here I have created a my struct and it has the properties of value. Here again the instance I have created is a constant. In that case, the copy of this structure is stored in this instance. Here in class I have informed as the reference of where this class is stored is assigned to this instance. But in structure, the copy of this my struct is stored in the instance. In that case, we cannot able to change the properties. Here we have defined this as a constant, so we cannot able to change the properties of value. Even though this value is stored as a variable, if we do this, we'll get an error. This is because the instance that we created is a constant. If we change this to variable, this error will go. This is what we are referring as value type. And here we have seen the reference type. The next important feature that we are going to learn in classes is inheritance. This feature is exclusively for classes alone and not for structures. As we inherit some of the characteristics from our ancestors, the same the classes can also do. See, here we have defined a class of dog and with the properties. This dog we can consider is a parent class, and we are inheriting dog class to the poodle class. That is, we can consider this poodle as a child class, so that this poodle class will be having the same properties and methods and the initializers of the dog class. If we didn't mention any initializers for this poodle, the initializer that mentioned in the dog will be taken. See, if I create an instance here for this poodle class, say I'll getting the initializer of the dog class. Here I can create like this. Also, if we want, we can create custom initializer for this poodle as well. See, we know that the breed will be always poodle for this poodle class. So we just want to mention the name alone. So we don't, every time while creating the instance, we don't want to provide the breed as well here. In that case, we can create the instance like this. This time we'll get the initializer that we mentioned for the poodle class. Here I just want to provide the name and the breed will be taken from the class itself, that is poodle always. So this init refers to the initializer of this poodle class, and super.init, it refers to the initialization of the super class, that is the parent class. Child class can have their own properties and methods as well. In that case, we need to mention the initializer for the properties of child class. See here, this is the child class. For the child class, it is having the property of favorite food. In that case, in the initializer of the child class, we need to mention the properties of this. Self dot favorite food, that is this favorite food equal to the favorite food that we are getting while creating an instance. And again we are calling the super dot init, that is the initializer of the parent class. In that class we have provided the values here itself. So while creating an instance for this poodle, I'll be getting favorite food to enter. So this we can enter. The same example I have rewritten as, instead of providing constant values for the name and breed, we can provide in this way as well. While creating again the instance for the poodle, we can mention the name, breed and the favorite food. Methods in class. See, for this dog class, we are having the method as sound. As I informed, if this dog class is accepting here as a parent, means this poodle class will also have the method of sound. If I print this, I'll get the answer as this will be printed. See here, if I want to print different sound for the same method for this poodle class, then we can override that. The same method I have used here, but I have used the override keyword because the method that we have in the parent class, we are overriding it and changing the print statement. In this case, if I'm creating an instance for this poodle class and printing this, means I will get the result as, within the override method, this statement is printed here. So this is the overriding method. The method we already have in the parent class, the same method we are overriding in the child class using the override keyword. And then if we call the method sound, then this one will get printed. This is the overriding method in class. Now we have learned about the feature called inheritance in class. But in some cases, we don't want our class to be inherited by other class. See here, the dog class is inherited by this poodle class. If we don't want this class to be inherited by others, in that case, we can mark this class as final. If we use final keyword before the class, it means this is the final class. We cannot able to inherit to the other classes. So this is for the final keyword. The next important topic that we are going to learn is deinitializer. This is also an exclusive feature for classes alone. We know that the purpose of initializer is to provide values for the class properties while creating an instance. This is the opposite of creating initializer. We will be denoting as deinit, deinitializer. That is the code that gets run when an instance of a class is destroyed. We have creating here an instance. If this instance is getting destroyed, the deinitializer will be called automatically. Because of this, we'll be performing a cleanup and thus preventing memory leaks or resource leak in our code. That is, this is the class we have, and we have a property called name. This is the initializer and this is the deinitializer. This will be automatically called. So in order to understand, I have made a print statement here. Here we are creating an instance and we have provided the name of object 1 and object 2. So two instances have been created here. While creating an instance, this will be called and this print statement will execute, and we are assigning the object 1, that is the instance 1 and instance 2 to 10 nil. That is, here the destroying of instance is happening. In that case, the deinitialization will be automatically called. So if I print this, I will get the result as, while creating an instance, I'm getting the initializing my class with the object 1, and again I'm creating the object 2, here I'm getting, and then I'm destroying the instance, that is assigning to nil. In that case, here this print statement will get printed, de-allotting my class instance with the name object 1 and again object 2. This is the purpose of deinitializer. It will help to prevent memory leak or resource leak in our code. So with this, we are wrapping the session for today. Thank you.